Hello, Physics Nation. My name is Nate Larmond. I'd like to do a Khan Academy problem from this set called Calculating Linear Momentum and Change in Momentum. So I'm going to bring up an old equation, Newton's second law. The net force equals the mass times the acceleration. And the trick is you just define what acceleration is. Well, it's the rate of change of velocity. So what's that? Well, change is always final minus initial. So all you do is you do V final subtract V initial, and then you divide by time to get the rate. So again, acceleration is the rate of change of velocity. And this is like how I like to write that formula. So, we've said a lot that net forces cause accelerations. If a system is in balance, it won't accelerate. That is, it'll either move at a constant velocity or it won't move at all. Dynamic equilibrium or static equilibrium. Well, Newton actually thought in terms of momentum. He said an impulse, that is, a force acting over some time, caused a change in momentum. So impulse is this thing, the product of force and time. And change in momentum is just final momentum minus initial momentum. So mass times velocity is momentum. So mvf subtract mvi. So this is usually how I take an old idea, Newton's second law, and change it into a new perspective. This impulse causes a change in momentum. What do they want us to actually do here? The change in momentum is this, 3.3 kilogram meters per second. And it takes place over 5 milliseconds. That little lowercase m means 1/1000th of a second. So, is that a reasonable time for the racket to actually contact the ball? I have no idea. All you do is you say sigma f multiplied by 5 milliseconds, again, that's 5/1000ths of a second, equals the change in momentum, which they're describing as 3.3 kilogram meters per second. So let's see, we undo multiplication with division. We're going to divide 3.3 by 0.005. What is that? Divided by 0.005. 660 newtons. So the net force is 660. Again, just 3.3 divided by 0.005. That is 5 milliseconds. 660 newtons. Could you impart a force of 660 newtons with a tennis racket? I don't know. Let me divide by 4.45. I'm an American. And 148 pounds of force. It seems big. I don't know. I don't know. Anyway, let's get this confetti. 660 is two significant figures. Thanks for watching. See you in the next video.